Hi everyone. Today I'm going to explain how to draw a graph and then we are going to explain the process of state of matter change from solid to liquid to gas. So for any graph, it contains three components. One is called the title. You have to include the title. It's very important. Otherwise, people doesn't know what we are talking about. Okay. And then there's x-axis and the y-axis. And for each of those, we have to label them so we can know what we are talking about. Yeah, here I'm going to use an example of a typical graph. So we're going to go through the detail for how to draw it. Okay. So again, this graph is talking about student class absences versus grade. So for each graph, it contains two variables. One is an independent variable, the other one is a dependent variable. For the independent variable is the cause. So the cause of student grades is the class absences. So class absence is the independent variable. So we always put the independent variable in x-axis and the dependent variable in the y-axis. That's very important. Okay, a title, x-axis independent variable, y-axis dependent variable. Okay, and then next thing is we need to label the x-axis and y-axis. And when you label them, how do you figure out the numbers? Okay, it really depends on what we are drawing. So for this graph, students number of absences are from 0 to 9. So I have draw this from 0 to 10. And then I separate this whole x-axis to 10 parts. And it's super important that you keep it as even intervals, means this distance from here to here is a 1, and you need to figure out another same distance from 1 to 2. So this difference is 1, this difference is another 1, this is another 1. Those intervals are the same because they have the same uh, difference. Okay, and for y-axis the same thing. Okay, how do you know what do you label? Because it's percentage, the minimum is 0, the highest is 100%. So I'm going to start from 0, end at 100, and then I separate this evenly to 10 parts. So I'm going to label 10, 20, 30. Again, those distances are exactly the same because they have the same difference. This difference is 10, this is another 10, this is another 10. Okay, so make sure you have even intervals on your, in the label of x-axis and the y-axis. Okay, and then you are going to start to label those dots. How do you find those dots? It's first you go to your x-axis. Students who have no absences, the average score is 90%, so it's 0, and then find 90 on the y-axis. You put a dot in there. And for students who have one absence, the grade average grade is about 86%. So you find it's 1 and then 86 and put another dot. For students who have two absences, okay, the average score is about 84%, you find another dot. So you keep on finding those dots. For some graphs you may need to fit it with a line, some graphs it doesn't necessarily to fit. Okay, so that's how we draw a graph. Hopefully it's a quick review for you, and we're going to have other opportunities to practice. Okay, now we're going to use this knowledge to draw a graph for phase changes from solid to liquid to gas. Okay, so for any substance, they can change phases when we heat it up or when we cool it down. Okay, for solid, it's the temperature for solid is low, and then when we heat it up and give it energy, it can change to liquid, and liquid absorb more energy and can change to gas. Let's have a look of the whole process. Okay. So imagine we have a setup in the lab. We have a hot plate in here and that we are heating up a beaker, contains some ice in there. Okay, those are the solid water. So a heater keep on giving it energy. We call it the amount of heat. And what is changing is the temperature of the material, the ice. Okay, so there are two variables. One is the amount of heat we give to the system, and then the temperature. Okay, two variables. Which one is the cause? Because we are heating it up, the temperature would increase. So the independent variable in here is the amount of heat. And the other dependent variable is the temperature. So we are going to draw this graph, but what kind of data do we have? Since we cannot do any lab, I'm going to use this simulation to show you. Okay, so let me stop at here. Let's have a look. Here's a container. And in here, this piece represent a piece of ice. And at this time, the temperature is 0 degrees Celsius. If you have a look, we are heating this up. At the beginning, it was totally ice, and eventually some of the ice become to liquid water, and some of those are still ice. Okay, we are inputting energy. I'm going to continue. We're inputting energy, but we are inputting energy. Ice are changing to liquid water, but the temperature is not changing. It's still 0 Celsius, because the energy we input into the ice, it become to liquid water. We call this the melting point. At this time, it's melting. So the melting point for water or for ice is 0 Celsius. And then we keep on adding more heat. And then eventually all the ice are gone, and all ice melts to liquid water, right? And you can see the temperature is still 0 degree. And if we add more heat, what's gonna happen is the water molecule is going to move faster and faster because it absorbs heat, and then the temperature would change. Well, it's heating up, temperature would increase. Temperature keep on increasing. Molecules are moving faster, but they are still like liquid water. Okay, still liquid water. The difference is more energy, moving faster, more kinetic energy, and the temperature increase until it's 100 Celsius. Look what happened. When it's 100, all the water just become to liquid water, become to gas, become to water vapor. The temperature again didn't change. We call this boiling point. Okay, now let's go back to here. We're going to look at this diagram. Okay, so this is a typical phase diagram for any state of matter. Okay, at the beginning, solid. Okay, this x-axis is the amount of energy we put in. This y is the temperature. We're supposed to label those. Okay, and then from the solid, temperature can increase until a certain point. When solid become to liquid, that's what we observed in the diagram. In that picture is 0 Celsius. The temperature will not change even though we are putting more energy. So we call this the melting point. And then once it all become to liquid, temperature would increase because we're putting more energy. The molecules are moving faster and faster. The kinetic energy increase until another point, which is 100 Celsius as water, and they start to boiling, and this liquid water will become to gas. Again, at this point, the material is absorbing energy, but it's the phase changing, but the temperature will not increase. That's why it's a plateauing here. Okay, so melting, increased temperature, and then this is boiling. This is boiling, and then if we keep the gas in a container, in a closed container, we keep on giving it energy, the temperature of the water vapor can even increase. Okay, so that's a typical diagram for phase change. Okay, you're going to watch a video, another video to understand this process better, and we are going to practice to draw this during the class on Friday.